You change disk. Editor.
Unit.
Usually.
Usually.
I'll try to just draw the picture.
You're out of a job.
This is a little different. Do I need to be concerned?
No, we're doing this thing.
Okay. You want to tag in?
No, I don't know what you're doing. Go ahead.
Oh, he's reminding us what a membrane was, probably regarding this.
Oh, great.
So, draw a picture now. Tau is a tangle.
I guess the picture we had was this. Okay. So with the question, what is a membrane?
I found it in here. It's
You're in here,
okay. I mean,
All right, so I think what I want to do first is just clarify what's sort of known about what the space of bridge splittings that different types of knots and links can emit, since I think I wrote some things on the board last time that were not quite right. Okay, so right, so what's known? So O'Toole proved that, oh, I want to know this, it's my old notes. Okay. O'Toole proved that the unknot has a unique B-bridge splitting for each B. Okay, just to get it that way. Schubert had proved previously that the rational link, or the rational knot, KMN, admits either one or two bridge splittings. Okay. And this is depending on whether n is equivalent to plus or minus 1 and mod n or not. And actually, I don't know if his m and n are the same as the m and I gave. We may never know. Okay, and so then O'Toole proved that every B-bridge splitting of the rational link, or rational knot, I guess here it should be a knot. Every B-bridge splitting of the knot KMN with B greater than or equal to 3 is perturbed. So it's a It's a perturbation of some other bridge splitting. Okay. So what doesn't follow from this a priori? I mean, what might have I tried to write?
What does printer mean here? I'm sorry.
Oh, that's okay.
The stabilization for vibration.
It's where you go from take an arc like this, and you do this kind of thing.
So it's printer from something that would be less than or.
It's like a reducible sort of.
Yeah. So in particular,
So- so
yeah, go ahead.
You mean the question of time, so in the case where there's two bridge splittings, we don't know how long it takes for them to become the same.
Right. Yeah. Good. So, and I don't know. I asked Alex, and I don't think he knew the answer, or he didn't know if the answer was known. So the question is, yeah, I see. You could phrase the question like this: does every two-bridge knot admit a unique three-bridge splitting? In other words, in the case where they have two different two-bridge splittings, do they become isotopic after a single stabilization? The other thing that's worth mentioning here is the following. So let's suppose we have splitting S3, S3K, or L, I guess, maybe. Okay, so suppose this is some splitting B. There, and no, we should be a little careful here. Now, how do I write this? So there's another splitting where essentially all we do is we relabel.
Union over.
Sigma comma vector x sub b. This is it's just a sphere with b marked points. I gotta be a little bit careful how I write this. But I guess we just how do I do this? So I guess we just write it. I guess we write it like this. That's it. I think this is what. Okay, I'm not sure if I'm writing this right, but the general idea is if we have a bridge and we just relabel the paths, right? Then a priori that's a new bridge splitting. Question of whether there's an isotopy that sort of flips it back to how it started. Okay. And so what's actually happening with these two bridge knots is exactly this: that the two bridge splittings for some of these two bridge knots are the splitting in its flip, and in some cases they're isotopic and in some they're not. But what's interesting in this case is that the bridge spheres are the same.
You want to say L prime?
No, same link. Yeah, it's meant to be two bridge splittings of the same link. I think I want to say. And I don't know, am I writing this right, you think? Okay, is this coherent? I'm a little worried about orientations and taking. I'm not talking mirror link, and so, but I don't think I want to think about mirrors today. But so it's a little interesting in the so the fact is that